Now let's take a look at 202 in your notes, where we're going to be diagramming Earth's orbit, outlining the key dates and events, and also talk about the distances during one orbit or one revolution around the sun. And we're going to start with summertime. Summertime coming up, we're talking about June, and we're going to come back to the notes in a second. I want you to take a look at the diagram that you're seeing on the screen. We're going to start with the Earth at June. You'll notice right away that the Earth is actually tilted. It's tilted 23.5 degrees towards the sun. So if we look at the diagram on the lower right, instead of being completely vertical, it's actually 23.5 degrees. And that tilt is, even though it's only 23.5 degrees, that is a huge, huge factor when it comes to causing seasons, which we're going to come back to. All right, so when this happens, 23.5 degrees, the northern hemisphere in this lower picture here is getting more direct sunlight than the southern hemisphere, which is getting less direct sunlight. We call that our summer solstice that occurs in late June, and the northern hemisphere is tilted towards. The tilt never changes. What does change is the orbit around the sun. So we're going to go from late June, and we're going to move on to now late September. When we get to late September, you'll notice it's hard to see the Earth, or the lighted side, because it's facing the sun, but you'll notice in this diagram in the lower right-hand corner that both northern and southern hemispheres are getting about the same amount of sunlight at the same latitude. So you won't have summer or you won't have winter in either hemisphere. Instead, we're going to call this fall. This is the fall equinox. The word equinox stands for equal, or equal day, equal night. On this day in September, which today I'm recording this on the 19th of September, in about a week from now, we're going to be at equinox. Equal day, equal night, 12 hours of darkness, 12 hours of daylight. And that's the equinox. If we move on to 3 months from now, we're going to be into December. And when we go into December, you're going to notice something happening, something a little different. Now, we're still tilted 23.5 degrees off of vertical, off of the zero. But in this case, now we're on the other side of the sun. And now who's getting more sunlight? Who's getting more direct sunlight? Look in that lower right-hand corner, you'll see that now it's not us, but it's now the southern hemisphere getting hit with more intense, more direct sunlight. And the northern hemisphere still gets sunlight, but it's less direct. And less direct means less intense, and that means we get colder temperatures. And that's called our winter solstice on December 21st, coming up December 21st of this year. And we finish off with March. And when we get to March, we're back to equinox one more time, just like in the fall. Equinox means equal day, equal night. Equinox also means that we have 12 hours of sunlight, and also both hemispheres getting the equivalent amount of solar energy from the sun, just like you see in this picture. All right, let's go back into your notes now and see if we can make a little bit more sense of this. Here's our diagram. Let's see if we can get this diagrammed the correct way. Let's start with summertime. Summertime tilted towards, and our northern hemisphere is getting more direct sunlight. We're going to call this our summer solstice. And we said this occurs in June. And what does that mean? That means we get about 18 hours of sunlight, sun, 6 hours of night. That's our summer solstice, longest day of the year. When we fast forward to September, this is our fall equinox. Equal day, equal night. This is September now. And this is going to be 12 hours of sun and 12 hours of darkness. So 12 hours of night. Fall equinox. When we move over, now we're in this part Notice who's getting more sunlight now. We have our southern hemisphere getting more sunlight, whereas here it was our northern hemisphere getting more sunlight. And we're going to call this our winter solstice. We know this occurs in December. And it's the opposite. This is our shortest amount of daylight. So we have about 6 hours of day, and we've got about 18 hours of darkness. Now that all depends on the latitude. So if you were to go to Florida, that's going to be a little different. If you were to go to the equator, it's much different. If you were to go to northern Canada or Alaska, it's much different than that. Let's finish off with our spring equinox. I'm going to abbreviate here, spring equinox. And we know equinox means 12 and 12. And of course, that occurs in March. All right. So our diagram is a little more cluttered, but one thing we know is that tilt has a lot to do with when we receive more or less sunlight. The last thing we're going to talk about on this 202 would be the distance. Now, you would think that in the summertime we're actually getting closer to the sun, but in reality we are not. On average, the Earth is 150 million kilometers from the sun. That's the average. In the summertime, though, we are 152 million. And in the wintertime, we're 148. Take a look at those numbers again. That tells you something very obvious, and that is summer, we're actually further from the sun, and in our winter solstice, we're closer. What this means is that the distance to the sun has very little effect on our temperatures. Instead, it's being tilted towards or away from the sun. The reason for the seasons is not distance. It's based on the tilt and receiving more or less direct sunlight. And that is 2.02 in your notes.